Hello and welcome to episode number 4 of Import Tutorial. This episode is titled Method and Scope. So in this we're going to learn how we actually declare methods. Actually I should have said the S there for methods. We're going to learn how we declare methods and how we can call them, and we're also going to learn a bit about scope for variables, kind of local variables, class variables, and kind of a bit about memory management. So let's just dive straight into this. What I want you to do is come down to the bottom of your class, come just above your @end, which is the end of the class, put in a few spaces so it's nice and comfortable. We've got a bit of white space here, and do a dash bracket void, close it off. This is how we're going to write our method. So here we put in our method name. So my method, put in a curly bracket, and yeah, that's right, I'm calling it a curly bracket, and press enter. So when we press enter, Xcode will automatically complete it for us, but if it doesn't, just close off that bracket. And this here is our method. So I'm going to just put in an nslog and say called method. So in our method here, we can put in whatever code we want. So put in whatever code we want. Of course, that's just a comment, but I'm going to show you exactly how we do this now later. So if we go down to the end of our init method, we'll just go underneath all our user interface here. So again, just above the return self. To call a method, you need to use the square bracket. I'm sure all these brackets have proper names, but I'm just going to call them the square bracket, and you can just remember to watch in HD, you can see which one I'm referencing. So put in the object name. So we're going to use self, which is the class, and we're going to say my method, and that is literally it. We close off the square bracket. Whoops, I don't know why I did that. I think it auto-completed for me by mistake here, so I'm just going to do that again. My method, close it off, and put in the terminator, and that is it. So what happens if we build and run, keep an eye on the log output, it should actually say it's done it, called method, which is down here. Another way to call a method is to use the perform selector. This is actually brilliant for, you put in the selector name here. This is brilliant for calling a method after delay. We can pass an object. I won't go into that right now. It's not too important right now, but we can call it after delay. So let's say we call it after 3 seconds. So imagine this init method here was our intro or whatever. We had an intro animation playing and it lasted for 3 seconds, and then after that then we wanted to go on to the next part. What we could do is we could have our intro animation built in here, and then we could say, right, go on to the next part, whatever the name of the method is, and call it after 3 seconds. So if we build that again, keep an eye on the log, we don't need to worry about the app. There we go, after 3 seconds, called method has been output. So that's how we declare methods. We do it as a dash void and the method name, and then we call out the method here. Now you might be wondering, why is it a small or a lowercase m, or well, lowercase and then kind of followed up by a capital R? There's actually a lot of methods here we've already been used in our class. So for example, one of the first ones we've used is for CC Sprite, which of course is the class. So CC Sprite is the class. You can see here it's in the square. So you can see right here has been a method being called. So basically what's happened is this is a way of declaring a message in the square brackets. So we're saying who the message is going to, which is the CC Sprite. And you can see here it says Sprite and then with image name, and this S is a lowercase, and then the rest of the words. So each next word following on word is a capital R. Same again for Apple's very own NSString. So NSString is getting past the message. So we declare a variable. Of course, we don't need to go into this right now. So we declare a variable NSString, and then we say string with format, and you can see again small s. Cocos2D again, the label, small l for label. So just for naming conventions, the best way to do it is for variables. So for example, variable, say my number, capital letter to start off your variable. For methods, lowercase. So very, very simple. So let's have a bit of fun with this now. So we're logging out here. I'm going to show you how we can have our, oh wait, actually before, I was going to show you how to do a bit of logic, but before I get into that, we can also do something really cool. For example, let's say we wanted to move all of this code into here. So we can change this. We can just get rid of this. We don't need the code. So we can say once intro logic is done, draw the start up of the scene. So what we're going to do here is we'll say draw scene startup. The startup, one word or 2 words? Well, let's put it as 2 words. So what we're going to do here is I'm going to just remove these 2 for now. I want you to go from where the end of the last label has been added all the way up to the top of your get window. So again, to highlight all that, you can literally just have your cursor select. You can just drag your cursor, or you can select it and hold shift and then select here and click, and it will collect it all. Do command X to cut it out. Get rid of some of that white space, and we'll move it all into here. So Command V, which is paste, and it's in here. So there's our intro scene being started up. So what I'm going to do is, let's say here in our init. So remember, this is where our scene has to be called. So remember, in our scene it returns self-allocate init. So this an instance basically. So this has to be called when our scene starts up. So we can have logic here for when our scene first starts up and stuff that we want. So for example, we can keep the self.user interaction enabled, which means it will get touch events. We can put in whatever logic we want here as well. So we can have, let's say, if I was debugging the scene, we can have a call, you know, call the debug setup or whatever, or we can call other methods. Like anything that you need for when your scene first starts up in logic, put it here. Once that's done, so now let's say we've done our logic. Now logic is called, now call our graphics, or call, whoops, graphics. Or now my spelling's all messed up because I made that one mistake. Now call our graphics. So again, we can just do self. Actually, what I'm going to do, so you can do self and just literally say draw startup scene, and it's called. But what I'm going to do is, just for demonstration, is use our perform selector. Remember, that's our code snippet that will automatically put this code in for us. It just makes it a lot easier. So again, draw scene startup, and we'll say delay again of 3 seconds. And there you go. After 3 seconds, our intro scene has now been drawn. So let's look at some other type of methods we can call. So if you want, first of all, you can collapse the method down here just by clicking on the side of here. So if you look right where the method is declared, there's a little arrow, just collapse it down. So another thing we can do with methods is we can pass in arguments. So we can say void, I would say work out sum of x. Now, to call the method, we put in the colon here. That is a colon, right? That double dotted line. I'm not too sure. Pass in an int, so put that in brackets, and we'll say the name of the integer for the variable. So we'll just say x value. Now, we'll also do space. Make sure you put in the space, and we'll say y, capital Y. Give it another variable. So again, put in the colon, brackets, int, and then our variable name, so y value. Now what we can do here is we'll do int total equals, and we'll say x value plus y value, and we'll do ns log, and we'll say total equals percentage I. Remember, that's how you log out a variable, or well, log out an integer with the percentage I, and then just put in the comment and pass it in the variable. So we'll say t for total, x will automatically do it for us. Now, whoops, I'm putting the terminator. So what's going to happen here is we've called our method here, so work out the sum of x, then we passed it in a variable, so x value, which is here. We've done a space, which means the method is still getting continued its name call. So we'll say y, and then we'll put in the kind of next variable for the y value. Now to call this, don't worry about the graphics on. I'm just going to leave that in there for now. We're going to work out our logic. So let's say, even if I was actually saying, let's say I said up here, we'll say work out our logic. So remember I said originally work out. I said let's call our logic first, and then we'll do our intro scene. Now of course we can have that draw pretty much instantly. You can even have a 0,0 delay and it'll draw instantly. So what we're going to do is we're going to do self work out the sum of, and you can see how this is wrote there. So you can see it's work out the sum of x, and we'll give it a value. So we'll say 10, and it'll literally just says y. So you can see the value for x, or x value and y value, because they're variables. They're not there in the method. It's just a method name. So you can see again, work out sum of x, and then the y part. So let's say a value of 5. So it should return 15. If we build this, keep an eye on the log more so than the app. Total equals 15. So another really cool thing we can do is we can have methods return something for us, return an object or return a value or return some sort of variable. So I'm going to remove this now here for now. So return this for now. Change down, so come down here and change the void to int. Now what's going to happen is you're going to get a warning. Now let's have a look at that warning. Or actually, sorry, not a warning, but a full-on error, red's error. The control reaches end of non-void function. Okay, so like it's like, what the hell's going on there? We have to return something. We have to return an integer. So we're going to say literally just return and an expression. So we'll say return total. Now what we can do is we can say int, and we'll say value of sum equals, right, so that's literally just an int variable, that's the name of our variable. So equals, and put in your method. So int, or sorry, square bracket self, work out sum, and again we'll just put in 10 and 10, so 20 that should return. Now what we're going to do here is I'm going to remove this NS log. I'm actually going to just copy and paste it. I'm going to remove it from here, put it in here, and we'll say value of sum now equals here. So again, ignore the app, just pay attention to the log down here. Value of sum equals 20. So what's happened here is we've declared an integer variable, and we go, right, I want to work out some logic here. I need to work out a value. So we passed in our logic, which is work out the sum of x and y, or two. So basically, we've worked out the sum of two variables to get a third variable. So work out sum. You can even pass in here another integer. So if we had int my x equals 10, and we could have another variable. What I'll do is I'll just say my x. You literally just put that in there, and that will stand for that number. So that's 10 plus 10 is still 20. So I'm just going to delete this here and go back into here. So again, what we've done here is now we've got int value of sum equals 20, and you can see here it's literally just we declared the variable, so int value of sum, and then we literally just called the method, and that was all we did, and we've got the variable. So now we could use that. So we could say if not too sure if I went into if statement. So basically, an if statement is if condition and then statement. So if value of sum equals. So you have to, that's a comparison, right? So it's not a setter. So if you just do a single equals symbol, it's a setter. So value of sum equals 20. But if we say equals 20, it means if this is equal to that, what happens? Put in the logic. So if value of sum is equal to 20, it means the or this code runs. So basically, if it's 20, whatever's in this bracket here will run. So that'll be our if statement. So we'll say if statement here, we'll just do ns log. Then you can put anything here. You could have like a sprite being drawn on scene for a certain reason. So for example, like I'm just trying to think off the top of my head, but if a certain state in the game was reached, or if the player got a new score, draw the label. You've got a new score, so then if player got a new score, you could have it as a boolean, whatever, for example, or whatever. Say, okay, work out if the player got a new score. If they did, return a boolean value of yes, and say if got a new score equals yes, and then put in your code, you got a new score, well done, or whatever. Okay, so it's really, really simple logic that you can do here. So we can just say this if statement code will run here in our output. So again, looking at ns log. Now I know this is kind of a bit of a boring episode, we're just literally looking at this, but this is all really valuable as we're getting along, and we can start piecing stuff together. And I'm going to go into scoping in a bit, which is a bit more interesting as well. So you can see here value of sum is 20, this code will run. If we change this here to even, now it's 19, you'll see value is 19, and that if statement did not run. But what you can also do with if statements is you can say else if, and put in the exact same again, else if condition. So if value of sum equals 19, bracket, this will run instead. Well, I'll say if it's, I don't know why I put a thing there. If yeah, you can do that. Alright, put in a comment if it is, if it's 19. Now another one you can also do is else, and that's it. So if it's 20, this will run. If it's 19, this will run. And if it's anything else other than 19 or 20, this will run. So again, if we say, we'll just say, so it's 14. We'll see, told you this will run. So again, because it's 14, there you go. See, I told you this will run. Again, if we change it back, so of course, just to put back, my maths here. I want to go to 20. So again, see, this statement runs. So you can see nowhere else ran. Now, of course, we have no log here, but you can see this didn't run at all. So there you go. That's how you do if statements. I don't think I've properly declared that before, but there you go. Very, very simple. Now, so we've returned a variable. Now we're going to get into a bit about scope. So if I say int total equals self work out sum of, and we'll just do 5 and 4, so it's 9. Okay, now we're going to get 1 just because we're not using this variable. This total here is not the same as this total here. And you might go, well, Stephen, it is. It's int total and int total. The way Objective-C works, and well, the way all programming really works, is most variables are contained as a local variable within the method. So this total here is erased from memory once this code ends. So once this method is finished, it cannot be used anywhere else. That's the end of that, like it's just gone. So we can use this for all our logic, all that type of stuff, all throughout this method, and then that's it, it's gone. Now, It's the same for down here as well. Like this total here is not the same, even though we're returning total. We're returning that value just in the method itself, but it's not return total as such. So I'm just going to name it something else. We'll just say value, just so you're not getting confused. Even though we're saying return total, it's actually just saying that's what the method is returning. So that's basically this method here is basically turned itself into an int. So int value equals this, but it's still only locally run. So that's the end of that as well. To use variables throughout a class, we have to go into the header file. I still don't know why I have to load a global variable in here. That's actually left over from one of the older methods. You can delete that if you want. So we can say int, and we'll say capital letter again. So we'll say my class int. That can now be used anywhere within our implementation. That's all we have to do. We just put it in the header file, my class int. It says I'm getting a warning. I don't know why the hell I had a warning there. I'm going to just build it just in case. Yeah, I had a red error. There, look, it's even there. I don't know. I literally do not know why it's giving red error and a little underscore there. So what we can do then is we can say, what did I name that there actually? I called it my class. Right, so, whoops. If you go in here, we don't need to redeclare it. So we can just do my class int, and you can see it's an integer. And of course, we don't need to do anything. We're not even getting any error saying because it's being used. Like it's being used in our class. We're not getting any warning saying it's not being used. And of course we can log it out. Now the cool thing as well is we can use down here as well. So my class int, and we can say int equals. Now watch this. We can say my class int equals plus total. So ignore this return total for now. Okay, we're just going to completely ignore that code. We're just going to focus on what's happening here. So what we'll do is, I will say, let's see, I don't know if that will even work, first of all. Okay, I have an idea. So we'll get rid of this for now. So we'll do a new one now. And we'll say void add 10 to my class int, or whatever I call it, okay? So we're adding 10 to it. We should be fine. So what we do is here in the class, we'll say my class int equals my class int plus 10. And what we'll do is we'll also, no, I won't do anything. I'll just leave it like that. So that's literally it. That's all we're going to do is add 10 to my class int. So what we'll do here is we're still going to, remember, work out the logic. Don't know what I got rid of that. Logic. So what we can do here is we can do my class int equals 15. Then call the method. So we'll say self, what did I actually call it again? Add 10 to my class int. And then what we'll do is nslog my class int equals %i. Again, passing the parameter, passing the int, and keep an eye on the log here. You see is 25. So what's happened here is this code has been set. So my int has been set at 25. It's now called this, so it's added 10, and anything under this method is now considered part. Like that code is just ran. Okay, so does that make sense? So my class int is 15. We call something here. It's made a change to that. It's added 10 to it. So it's continued on down here. So anything down here, it's almost as if we put in code here. It's just that it's condensed down here. So we could put in as much code as we want here. We call it as a method. We'd call the method here, and that code is now considered ran. Now I want to show you something else that's really interesting here. If we call it using the perform selector, okay, so I'm going to just comment this out. So remember, it's commented out. I'm going to copy and paste that in. I'm going to keep the delay still at 0, 0 and build it. Now, did you notice it? My class is equal to, or my class int is equal to 15. When you call a method using the perform or the self perform selector way, rather than kind of just send the object the method, this is run after all of this code. So after this part ends, it's then called. Even if its delay is 0.0, it's still called after this part down here. Okay, so that's very, very important, because what you can have then is you can have something like logic working out here, and then you can go, right, well, I want this to be called after. And I'm trying to think where I might have used it even as an example in XenForms. But again, it's very, very handy that if you want to do something with logic here and then pass in something down there. So does that make sense at all? I hope so. So that's how we're going to use variables. And again, if you want to work basically if you want to work instantaneous, you put in the simple way of the self, call the object method. For anything else, even though it doesn't have a delay, we can give a delay as well. It's still running this code. It still is running. So we'll just put in nslog. We'll say this code ran. So I'm going to just build that real quick just to show you. So just to prove it is running. So this code ran. So it still ran. It still ran at 0.0 delay, but the logic itself is worked out after basically this is then closed. So I really hope that makes sense. Right. So that's how we declare methods. That's a bit about scope of methods and kind of class variables. So that's how you declare. You can put any variable you want in here. It can then be used anywhere else. You can have local methods. We can call out the sum of a method. You can call out the sum of methods. We can call out whatever we want. We can call out logic. One last thing I want you to do is scroll all the way up here, and you can see here I have some comment lines, and we have this thing called a pragma mark, and I have create and destroy. What I'm going to do, I want you to highlight all that, Command Z, copy it in. Come down here and we'll say, just paste it in. Go down to where you put in here, paste this in. Now what we'll do is we'll say, change this to logic methods, whatever. You can call it whatever, we'll just say logic actually, to make it simple. Here we can call this part intro. Now, what does any of that mean? Come up here to the top of your Xcode, kind of in the middle of your panel here. Click on this part and you can see it's actually nicely and neatly broken. We can easily jump to methods. So look, there's the draw set. I'm just going to expand it out just for now. But we can easily jump to methods, so we can say, right, jump right down to add my class int. Done. And the only thing that this does is makes that jump method look pretty, and it makes it, I don't know why I said pretty, really funny there, but yeah, it makes it look pretty, and it kind of just makes it look really kind of a lot more neat, especially in this part. So you can hear we have a create and destroy methods, and it allows us to organize everything, so we can put everything to do with our intro into this section here. So you can put in intro, we can even put in intro logic if you wanted to, but I'm just saying, for example, we can have intro, we can have another method that does let's say void animation for intro or whatever. Like, we can put in all the intro related methods in here, and then for our logic, don't worry about that, just build that off. It's just giving me the auto error there because that method. And then we can put all our logic down here, and it just makes it look a lot neater. And even if you want, you can just do the pragma mark without any text, so pragma mark and the little dash, and it just really organizes out. So wait, hang on, I didn't actually do it there because there's no other methods, but if I put in a method down here, so we'll just say void another method. So you can even put in a dash, and you can see it adds basically just a horizontal line into your kind of code. So it just makes it look a lot neater, and that's something I want you to start doing as well. So organize out your code. And that's going to be it for this episode. It's been a rather long episode, but I've taught you how to kind of call methods, how to work out logic, how to pass logic into methods, how to return logic from methods. I really hope you understand it. If you didn't remember, I can understand that this part may be a bit confusing, the kind of why is it kind of this gets called after this and stuff. So feel free to ask me any questions. I will hopefully try get another episode out in 2 more days, which will show you how to kind of reference other CC nodes in another method. I was going to plan to do it this one, but it's going to run a bit long. So I'll do it hopefully in another method. I'll probably call it episode 5. If not, it'll be episode 4 part 2 or whatever. So thanks for watching, and be sure to subscribe if you haven't. Be sure to ask me any questions, as I said, if you're confused at all, and I look forward to helping you.